welcome to our next video of Video Geeks. So today we have Anil Mistry. So how are you, Anil?
Yeah, Harshil, I'm fine. What about you?
I am doing also well. So what is your today's topic?
So we'll see that what is STP. So we'll continue. We'll look what we have seen in the last video because this is the second video of STP series, and from there we'll deep dive into STP. So
Okay.
for yeah, you were there in last video, right? And
Yes,
you
I am there.
now know, and you now know a little bit about STP. That what is it and how it works.
Yes, I know a little
So
bit about.
yeah. So for the viewers who might be first time, for them, let us just revise what we have seen in the last video. And anyways, if they want to see the full video, I will ping the link of that video in the description.
Yeah,
So
that
in
will
the
very helpful.
yeah, yes. So just a second. So in the last video, we have seen all about these three terms: transparent bridging, unknown unicast and broadcast, and the basic what is the meaning of STP. So we have seen the transparent bridging. That means that let's say whenever there is a packet going over the layer 2, we don't have the information that how many hops the packet has been gone through. So that is because of this term which is known as transparent bridging. Then we have seen that what are the uh, uh, what you can say events when the switch will broadcast the packet. And by this simple example, we have seen that how STP works, what are the terms, ports, and how it will be block the ports and not block the ports so that the topology will not contain the loop. So in today's video, we will see the more new terms about STP and detailed information about how STP works. So we'll deep dive into STP today. So let's start. So in today's video, we'll look at these many terms: BPDUs, root bridges, port roles, port status, bridge timers, and the structure of spanning tree. So BPDUs are new actually packets, type of packets that are basically designed by Radia Perlman. You can also, I don't know how to exactly pronounce the name. So basically, she designed this uh, entirely new packet, or you can say she was the one who designed this protocol, which is known as currently spanning tree protocol. Previously, it was known as bridge protocol data unit, and now it is popularly known as spanning tree protocol. So this is the packet structure of BPDUs. So these are BPDUs that are entirely exchanged over the switched network for making a spanning tree topology, so that there will be no loop in the existing topology to avoid network congestion and broadcast ROMs and all that stuff, right? That we have seen discussed in the last video. So these are few terms: protocol ID, protocol version, BPDU types, flags, root ID, root path. So we'll see about all this. But before going to that, we have three types of BPDU exchanges. So basically, when the switch will exchange the BPDUs, like these packets between two switches, that when they will exchange, there will be these many types of BPDU exchange. So the first is CBPDU. So basically, that is the most common type of BPDUs that it will be exchanged. Another one is TCN BPDUs. Basically, that is topology change notification BPDU. Then the last one is PCA BPDU, which is known as topology change acknowledgement BPDUs. So that are the three types of BPDUs, and as the name suggests, so topology change notification, that is basically these packets, these BPDUs will be exchanged when there is change in the topology, and topology change acknowledgement BPDUs that will be exchanged whenever this TCN will be exchanged. So for that acknowledgement of these packets, these BPDUs will be there, and this is the initial BPDUs. So now let us just discuss about what are the port roles in the spanning tree protocol. So whenever there is a spanning tree in the switch network, so you might know that what is the port. So switch will contain multiple ports, right? Most of the switches are in the data center, they will be modular switches. So they will be having lots of ports. But let's say a normal switch that will be having, let's say, 24 ports. So each and every ports will be having some of the roles assigned to it. So those are root port, designated port, alternate port, and backup port. So before understanding these port roles, let us just understand what is root bridge. So as discussed in the last video, root bridges, it is the center of the topology. So basically a spanning tree instance has only one root bridge, and the path calculation in the spanning tree, that is based on the root bridges. So every other switches that is not a root switch, they will be find a path, or you can say the less distance path from itself to the root bridge. So root bridge is basically a switch only. So now according to that, there are these four rows. So root port, basically that is the port that is connected to root bridge. So let's say there is switch, I will explain by this example. So let's say this is the root switch, this switch, and this switch, Ethernet 1 port in this switch, it is connected to Ethernet 1 port of this root switch. So this port will be root port, basically because this port is directly connected to root bridge. And for this switch that is below this switch, this Ethernet 1 port which is connected to this switch in Ethernet 5 port, it will be root, what you can say, root port, because you can directly go via this switch of this port to this root bridge. So that's how root port works. Then there will be a designated port. So a designated port, that is the what you can say, any other port which is, you can say, part of boundary, or you can also identify a root bridge via designated port. So all the ports in the root bridges are designated port. So that is the fact. And let's say alternate port. Alternate ports are blocked ports. Basically, they will not receive any packet. So basically, they are blocked by STP protocol to avoid any network loops. So for this example, one of these ports, one of the Ethernet 3 port on this switch or this switch will be alternate port. It is not necessary also I will tell you one thing, it is not necessary that both of these sides will be in alternate port. It is not necessary, or it is not, you can say, it will not always be that it is this is the alternate port and this is also alternate port. So two of the ports that are connected to each other, they will not be having same role. And last one is backup port. So let's say when there will be a one switch goes down, then if there is a situation, if there is a possibility that turning on this port will keep your network running up and running, so that port will be counted as backup port. So having this port in your spanning tree topology is very rare. So these are the port roles. Now port statuses. So according to port roles, there will be 3 port statuses: forwarding, discarding, and learning. A learning stage is very initial stage when STP protocol is running and the port roles has, you can say, not yet assigned. Discarding means the traffic is coming, but switch is dropping all the traffic from that port. So basically the alternate ports, they will be mostly having this discarding status, port status. And the forwarding means that port is actively accepting the traffic and forwarding the traffic. So all the root ports and designated ports, they both will be mostly having forwarding status. And these are the timers. So these are the bridge timers. So hello time, that means STP will always per interval of time, it will send a packet that if you are what you can say, you are let's say you are up and running, you are active, so that is called hello timer. One is forward time, one is max age time and max hope time. So these are, you can say, not that much needed to understand. So these are basically bridge timers. So let us do some things. Let us observe the practical things. So that was basically the theory. Now let us just open this Cisco Packet Tracer. So I haven't included Cisco Packet Tracer in activity yet. So this is the, after a long time I am also experimenting with the Cisco Packet Tracer. Harshil, have you ever used this Cisco Packet Tracer?
Yes, in my college and computer network course, I used it. But for
Okay.
simple usages like DNS and HTTPS was
So what was the last time when you have used this software?
I think in 2 years.
Back in the exams?
Yes,
Okay, okay. So, so that's the situation. I also used it.
yes,
Just I am also used like it in the last week for the experiment purpose. So let me make a topology. So let us just name it
yes.
as spine one. Let us just name it as SPINE, spine 2. And now, so these are basically switches with all the switches with the 24 port. Leaf 1, leaf 2.
You are building same topology as 2
Let me just, I don't know what was the actual topology. No, I will make another, I mean, different topology.
Okay.
Or we can make the same topology as well. There are, okay, one, okay, I can make it. Let us just put this aside. Leaf 1, leaf 2, leaf 3, leaf 4. So this is the same topology as this, right?
Okay.
And let us just now connect. So let me see the connections. Okay, okay, okay. Two ports, cross connection, and then okay. So I will use this. I will connect this, then I will connect this, and I will connect this. I will connect this, and I will connect this. Now two connections from here to here, and from here to here. So I think this is now the same topology, right? Crisscross,
Yeah.
double connection. This is, yeah. So now let me just fast forward this network. So basically, if you go under this simulation section, then you will see all the BPDUs exchanges. You can observe all the BPDUs exchanges that is happening over here. See, if you will observe the packets, you can see destination is STP multicast, and you can observe the packets. So route path, you can see cost, bridge ID, you can see port ID, message, forward delay, hello time, all the fields that we have seen, you can observe it here. You can observe how BPDUs are exchanged and how you can see these ports are turning from amber to green. So green one is port is active and accepting the traffic, and amber means the port is not active and not accepting the traffic. We'll go to the real time first, and we'll fast forward it. So using this button, you can fast forward the network. Okay. And now, let's say on this spine one, under the CLI, we'll go under these privilege executable mode, and for that we'll need to type enable command. So we are now under the privileged executable mode, and from here we can issue show spanning tree command to see the spanning tree. So you can see this is not a root bridge. So basically, if it is a root bridge, then you can see all the port roles should have been designated. You can see this is root port and this is designated port. So root port is fast Ethernet 0/1. So this is fast Ethernet 0/1. So this might be root bridge. So let's just observe how I am assuming that, because this port is having root role assigned to it. So basically root port is the port towards you can say the root bridge, which can lead you towards the root bridge. And you can see all the ports over here are green. So basically they are accepting the traffic. And let's say this, if this should have been root bridge, so this ambers should not be here. So that's why I am assuming that this switch should be root bridge. So to verify that, we'll again go to privileged executable mode and we'll issue show spanning tree command. So you can see this bridge is a root bridge. So this is a root bridge, and you can see all the port roles is designated, and status is FWD, that means forward. And you can see there are no ports that are being that is forming a loop. So basically this amber, that means this port is blocked. So this port will not accept the traffic, so this port will not form a loop. So you can see this is topology, and there are no way possible that we will find a loop. So basically this is amber, this is also amber, this is also amber, so there are no loops over here. So that's how STP works. And if you want to see the packets, then you can always go to this simulation. You will see this BPDU's exchange happening every few seconds. It will not stop because STP is continuous. And now if we want, let's say if we want to make this switch as root by force, then also we can do that. So let us do that. So for that we can just issue this command from the configuration terminal, or you can say from the global configuration mode. We'll issue this command spanning tree and then VLAN, for the VLAN 0, and let's say configure switch as a root. So we'll write root, and what is the root that we want it to be? So this is primary, we want to be as a primary root. Okay, there is no such thing as VLAN 0, there is VLAN 1. I forgot it. And now I will just fast forward it, and you will notice some ports turning, status will change. Okay, so now we'll verify. So under this spine 1, from the privileged executable mode, show spanning tree, you can see this is the root bridge now. And if we go to this leaf 1 privileged, show array, we need to wait for this to end. Let us just fast forward. Okay, now so spanning tree, so you can see this is not a root bridge now, so because this is a root port and there is designated port over here. So you can see now we can also verify the topology. So here this was the final topology. So basically these were the connection, this is the connection. So now we just need to verify that all the connections are blocked. So you can see this is blocked, this is blocked, and also this is blocked, and this is blocked. Okay, so this spanning tree instance has made this active connection and this is blocked row. So basically this to be this and this to be this. So this is the actual connection that spanning tree has made over here. So that's it for spanning tree from me. Hopefully you have got the idea. If you have any questions, Harshil, then you can ask.
Oh, this is very interesting and you are explaining very well. I don't have any question.
Okay. So yeah, that's it from my side. Hopefully you have got the idea about spanning tree protocol. It's working,
Yeah.
and yeah, that was it. We have also seen the simulation stuff. So thank you.